Hello, my chemistry peeps, and welcome to this first screencast of the school year. So today we want to talk about chemical and physical changes and what all that entails. So first, let's talk about the two ways that we can change matter. The first way is through a physical change. So this is something that only affects the physical properties. So things like hardness or boiling point or freezing point. These are things that we can measure of a substance without changing what it is. All right. Another thing that we can measure is density. And again, this is the ratio of something's mass to its volume. And it's expressed in either grams per milliliter or grams per cubic centimeter. Okay. The other ways that we can change matter is through a chemical change. Now, in a chemical change, we are creating new substances. So this is kind of like where the atoms are going to come apart and they're going to rearrange themselves into something brand new. Some chemical properties are those properties that we can measure only when something reacts with something else. Okay? So let's take a look at a quick example. Our reactants here are going to be two molecules of water. So we have H2O and another H2O. If we apply some energy here, like a spark, that is enough energy to get these bonds to break and these atoms to rearrange themselves. We end up with brand new compounds in the form of one molecule of oxygen gas and two molecules of hydrogen gas. So we can see two atoms of oxygen, four atoms of hydrogen, and two atoms of oxygen and four atoms of hydrogen. But the way they're bonded in the products is different than the way they were bonded in the reactants. We've created these brand new compounds. Rearrangement of atoms, that is a chemical reaction. Now, sometimes chemical reactions also involve a change in their amount of energy. So that means that sometimes reactants have more energy than the products. So if I have the reactants that are going in having more energy than the products that come out, this extra energy that we started with is given off to the surroundings. And for example, if your finger is sitting out here, so there's your finger, and if your finger is sitting out here to absorb this energy, well, what happens is that your finger feels that energy and your finger gets hot. So because this energy is being released from the system, from the reaction out to the surroundings, we say that this is an example of an exothermic reaction. So exothermic reactions release energy out to the surroundings, and because your finger is part of the surroundings, your finger gets hot. Sometimes the products end up with more energy than reactants. Okay, so again, let's look at the same example. We have our reactants and we have our products. Well, in this case, the products have more energy than the reactants that went in. So this extra energy has to come from someplace, and it comes from the surroundings. It comes from outside and it goes in. And again, if this is your finger out here, all right, so there's your finger, and if your finger is here, it's going to take, the reaction is going to take energy from your finger to put it in the products. So what happens is that if it's taking energy away from your finger, well, that energy is heat energy. So now what happens is that your finger feels cold. All right, so this reaction is pulling energy out of your finger to store it in the products. So we say because the energy is going into the reaction, this is an endothermic reaction. Okay, that's it.